Hello everyone. In this section, we will talk about what is regression. We have introduced that machine learning has three types: supervised learning, unsupervised learning, and reinforcement learning. While on the supervised learning, we have two classes of problem that we will deal with. One is the classification problem, and the other is regression problem. We will introduce classification in the next chapter. Classification predictive modeling problems are different from regression predictive modeling problems. Classification is the task of predicting a discrete class label. Regression is the task of predicting a continuous quantity. There is some overlap between the algorithms for classification and regression. For example, a classification algorithm may predict a continuous value, but the continuous value is in the form of a probability of a class label. A regression algorithm may predict a discrete value, but the discrete value in the form of an integer quantity. Some algorithms can be used for both classification and regression with small modification, such as decision trees and artificial neural networks. Some algorithms cannot easily be used for both problem types, such as linear regression for regression predictive modeling and logistic regression for classification predictive modeling. Importantly, the way that we evaluate classification and regression predictions varies and does not overlap. For example, classification predictions can be evaluated using accuracy, whereas regression predictions cannot. Regression predictions can be evaluated using root, mean square error, whereas classification predictions cannot. Now, let's begin our session with what is regression. Regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent and independent variable. For instance, we want to know if there is a relationship between the weight and height of a person. If yes, then how is it related and how strongly? Regression can be used here to arrive at a conclusion. Regression analysis is used to predict the value of one variable, the dependent variable, on the basis of other variables, independent variables. In the simplest form of regression, linear regression will work with one independent variable. In the simplest form of regression, linear regression will work with one independent variable. Now, let's look at some examples of regression analysis. Regression analysis is used in several situations, such as those described in example 1. Using the data given in the table, we have to analyze the relation between the size of a house and its selling price. In example 2, we need to predict the exam scores of students who study for 7 hours with the help of the data shown in the table. In example 3, we have a dataset having 5 columns, namely user ID, gender, age, salary, and purchased. Now, we have to build a model that can predict whether on the given parameter a person will buy a car or not. Supervised learning has been broadly classified into two types: linear regression and logistic regression. So next topic is linear versus logistic regression. In simple linear regression, we are interested in things like y equals mx plus c. So what we are trying to find is the correlation between x and y. This means that every value of x has a corresponding value of y in it if it is continuous. While in logistic regression, we will not fit our data to a straight line. We map y versus x to a sigmoid function in logistic regression. What we find out is y is 1 or 0 for this particular value of x. Thus, we are essentially deciding true or false value for a given value of x phi. So what's a core concept of linear regression? You can see that the data is modeled using a straight line. While in the case of logistic regression, the data is modeled using a sigmoid function. The linear regression is used with continuous variables. On the other hand, the logistic regression is used with categorical variable. The output of the prediction of a linear regression is the value of the variable. On the other hand, the output of prediction of a logistic regression is the probability of occurrence of the event. This is the end of this section. Thanks for watching and welcome to the next period.